Okay, welcome to the August 28th OMR Architecture Meeting. Today we have a compiler topic that Henry wants to take us through, so I'll turn it over to him to take us through a value propagation topic.
Okay.
You're going to present your slides?
Sure. All right, so just to provide a little bit of background before I dive in. So value propagation is an optimization that's in OMR that downstream projects are capable of extending. In particular, there's a particular part of the optimization that gets extended by OpenJ9 that OpenJ9 ran into a problem with. And because there could be other downstream projects that extend this optimization as well, I wanted to make sure that any changes that happen to resolve this problem can be dealt with in the same way across different extensions of value propagation, and also hopefully settle on a particular approach to resolving this problem. So let me just share my slides here. Okay, can you see my slides?
Yeah.
All right, so the first thing I wanted to do was just describe the particular part of value propagation that's involved here, which are the delayed transformations that value propagation performs. Also, I'll describe what that part of value propagation does, or I'll more briefly refer to it as VP. Then I'll describe the actual problem that has arisen, and then go on to some possible solutions that I've thought of, and hopefully either we can decide on one of those or come up with alternatives. All right, so to start with, what are delayed transformations in VP? So when value propagation is going through performing its transformations, most of the transformations it performs are performed while it's walking through the trees. But there are some transformations that it wants to apply that are more involved or might introduce new nodes that don't have values that VP knows about. So it delays performing those transformations until the end of VP, until after it's finished walking through all the trees in the IL for a method. So the trees or nodes that are going to have delayed transformations applied to them are stored in various lists or other structures that VP knows about. And at the end of VP, this do delayed transformations method is invoked, and it iterates over the entries in those lists and performs the appropriate transformations for each one of those. So this is a list of some of the data structures that are used in OMR's value propagation implementation to perform delayed transformations. So there's a whole series of these that are specific to particular transformations that are going to be applied at the end of VP. Some that apply, there are a number for array copy operations, transformations that can be applied. There are various others. I won't go into all the details of these, but just point out that there's a long list of these things that VP has to worry about. And then a tiny extract from do delayed transformations itself. This is typically the sort of thing that happens in do delayed transformations. It will grab one of the lists that I showed on the previous slide and create an iterator object, iterate over the entries in that list, and each entry typically contains a reference to a tree or a node in the IL, and the loop will perform the particular transformation that's needed for that particular entry in the list. So there are several instances of these that you'll see. Do delayed transformations basically consists of a whole series of these loops that iterates over entries in a variety of lists and performs specific transformations on each of those entries. Similarly, in a downstream project, there will be a do delayed, or there can be a do delayed transformations method. So the do delayed transformations is a virtual method, and downstream projects can override their own version. So in particular, OpenJ9 has an implementation of do delayed transformations that performs similar iterations over lists of delayed transformations that are specific to OpenJ9. And then at the very tail end of it, it calls OMR's do delayed transformations to perform the additional transformations that are generally applicable for OMR. Now, this is the problem that has arisen. There's a particular situation, well, a common thing that value propagation does while it's processing things is that it looks for values that it knows about and can sort of specialize trees based on the values that it recognizes in other nodes, or in particular nodes in a tree. So, for instance, if a block ends with an if comparison operation, and value propagation recognizes that the comparison is always going to be true or always going to be false, it will either remove the branch completely so that the block will fall through to the next block, or it will replace it with a goto, depending on the kind of if that was involved and whether the result was going to be always true or always false. When it removes that node or replaces it with a goto, it doesn't make any changes to the control flow graph. So the block, even though it will transfer control flow either to the subsequent block or to the block that's targeted by the goto, it will still have two successors listed. And that's because VP waits until do delayed transformations to actually remove the edge that's no longer needed. Now, there are other transformations that happen in do delayed transformations that have to wait until after control flow graph edges have been removed, in particular inlining. Because inlining can copy blocks or replace blocks, it's possible that a block that was supposed to have an edge remove could end up being copied by inlining and placed elsewhere. Do delayed transformations will have no knowledge of that newly created block. So if a block that had two edges that was listed as having two successors coming out of it needed to have one of those edges removed, do delayed transformations would go looking for that block. It wouldn't necessarily find all the instances where that block had been copied and those edges had been copied. So there might be all these spurious edges floating about that shouldn't be there. So inlining has to happen after CFG edges have been removed so that it doesn't end up copying any of those edges that no longer should be in existence. And it's possible that there could be other transformations that could do things to the CFG as well that would be run into a similar predicament. So this is just the particular area of code and do delayed transformations where that sort of thing is happening. Right now in OMR's do delayed transformations, there's a list of edges that are known to need to be removed. It iterates through those edges, removes them, and then performs the inlining transformations that it needs to perform. Now, here's where the actual problem comes in. In OpenJ9, we recently introduced an inlining transformation that happens in OpenJ9's do delayed transformations. But because that inlining happens before OpenJ9's VP calls OMR's do delayed transformations, we end up with a situation where the CFG edges that should have been removed have not yet been removed. So inlining goes ahead and modifies, makes copies of blocks that cause spurious edges to be copied. The OMR's do delayed transformations then goes ahead and iterates over those things, edges. It ends up failing to remove a newly created edge that shouldn't be there. And we end up with a crash during code generation eventually. So this is one particular instance of an ordering dependency that exists in do delayed transformations. It's possible that there are others. One particular one that I know exists involves array copies. There are some array copy transformations that happen during do delayed transformations that actually introduce additional delayed transformations. And those obviously have to come later in OMR's do delayed transformations so that they'll be evaluated and performed properly. So it's possible that there are a variety of other ordering dependencies that exist in do delayed transformations. I'm not sure how many there might be. They could all, as I said, there's quite a few different transformations that are being applied today. Before I go on to the possible solutions, I want to just double check if anybody has any questions on the portion that I've described so far, the do delayed transformations or the nature of the problem that I've described. Okay, if not, I will go on to potential solutions. So the initial solution that I thought of when I first encountered this problem was the possibility of introducing a do delayed inlining transformations. That would be a virtual method that OMR's VP would define, and it would contain the inlining transformations that it needs to perform after it has removed or manipulated the control flow graph. And OpenJ9 or any other projects that need to perform inlining transformations could override that method so that it would be called after the CFG manipulation has happened. So OpenJ9 in particular could override do delayed inlining transformations. The one inlining transformation that it needs to perform today could be placed in there after the CFG changes have happened. Then it could dispatch to OMR's do delayed inlining transformations to perform its inlining. this would solve the problem for this particular case, but the main drawback I see with it is that it's very specific to this one kind of transformation that needs to be delayed, and the fact that it needs to be delayed until the CFG manipulation has happened. A second possibility that I considered would be sort of refining things a bit further, where we could sort of abstractly divide the delayed transformations that VP needs to perform into early, mid, and late delayed transformations. The mid transformations could contain the CFG manipulation that I described. The late transformations could be overridden by OpenJ9, and OpenJ9 would inject its inlining transformations there. Similarly, OMR's inlining transformations could happen there as well. And all the other transformations that OpenJ9 performs today could be lumped into the early category. OMR's could be some lumped into the early, some lumped into the late as appropriate. It sort of abstracts away a bit more from this specific problem, but it's doesn't necessarily allow for the possibility that there could be more complicated ordering dependencies that could come into existence in the future. In particular, it doesn't necessarily account for this the array copy ordering that I briefly described earlier. So a third possibility that I was thinking about, and I prototyped to some extent, was the possibility of introducing a delayed transformation class in VP. The subclasses of this would implement an apply method that would apply a transformation that's specific to that particular type of delayed transformation. Then VP would have a single queue in which it would track all transformations. It wouldn't have all 10 or 15 lists of different kinds of transformations that it needs to track. Whenever an opportunity for a delayed transformation was found, that part of VP would create the appropriate instance of a subclass of delayed transformations, add it to the one queue, and then OMR's do delayed transformations would simply iterate over that queue and call the apply method on that instance, on each instance. The one concern that I had about that, or one possible drawback I see with it, is it might consume a lot more memory than the lists that we have today. I'm not sure how many delayed transformations VP typically keeps track of in a very large method. So this would potentially greatly increase the amount of memory that would be needed to track all those delayed transformations. So it could be that we would have one instance of delayed transformations and have lists in each of those things, basically relocating the lists that VP has today and moving those lists into each individual kind of delayed transformation. But that part aside, the important thing here is the possibility then of declaring partial orderings, or it could be a total ordering of the different kinds of transformations that would be applied. So when a VP instance is initially created, we could register, OMR could register partial orderings of the transformations, the kinds of transformations it knows about, and downstream projects could then register their own additional partial orderings. So in particular, OMR could register the fact that inlining transformations have to happen after the CFG transformations, and OpenJ9 then could take advantage of that without any additional changes. Similarly, the array copy transformations could be different instances that would have a partial order defined between those things. The one major drawback that I see here is the possibility that this is maybe way more complicated than it needs to be. And the one worry I had is whether declaring the ordering could be error prone, whether it might introduce difficult to debug problems. But it's possible that those problems exist already with the hard-coded ordering that do delayed transformations has today. So those are the three possibilities I came up with. I don't know if I'll open it up to people to sort of provide their thoughts on whether one of those might be preferable to others, or whether anybody might have additional other ideas that I hadn't considered, or if, yeah.
So solution 3 is still, the order here is an order of categories of transformations. It's not individual transformations.
Right. Yeah, so it would be on the kind of subclass as opposed to each individual instance.
You had concerns about the footprint of that approach. I mean, what are we talking here? Like small numbers of like how much data do you need to represent each transformation there?
Not necessarily. What I was imagining was that it might say double or triple the size versus the lists that exist today. So I'm not sure how much space those lists are taking today. So if those are we're taking a megabyte, then we'd be 3 megabytes, say, or something like that. If they're taking 2 kilobytes, then we're talking 6 or 8 kilobytes. So it's not. I'm not sure. I don't have a handle on how many delayed transformations we would typically have.
Big methods can do a lot more transform, but I'd be surprised if those lists were a significant part. So if you can 2x that memory, I'd be surprised if that showed up.
You should be able to instrument and measure that.
No, I hadn't yet. So it was, was just
when you were originally talking, and I kind of predicted what your problem was going to be before you got to the problem. And I was trying to think in my mind how you could solve this. And what I kind of was coming up with in my mind, at least, was sort of what your option 3 was if you could, which I think is kind of the cleanest solution. It's I mean, I'm sure you can squeeze it to the point where you can probably make it as memory efficient. If that is really a concern, you can probably make that as memory efficient as possible. But it does seem to be the most flexible solution. It obviously needs development work that, I mean, you have to be careful about, the quality of the code changes that, because you are changing some code that's probably been fairly stable for decades.
Yeah.
But if it's the right thing to do, then that's okay. So, but anyway, my personal inclination is towards something like option 3, but others could.
Yeah, these 3 options, definitely I also go in favor of option 3. Doesn't solve the problem.
Oh, sorry.
Good. I'll give it to you, Devin, in a second, but it doesn't solve the problem, right? Like in the sense that it gives you an easier way of expressing these kinds of dependencies, but things could still go wrong, right? And I wonder if a solution that tries to detect that something is going wrong, that's something to consider. I don't know how easy that would be or how we would do that, but that's something I can go off and think about as well.
Okay.
Go ahead, Tim.
Trying to detect that kind of thing automatically seems to me like sort of first reaction is to think that that would be extreme lex, but maybe not. But I wanted to say in terms of the memory, somehow I doubt that it's more than, say, plus about 50% or maybe a bit more. But if you think of the current lists, are they linked lists?
Yes.
Right. So each of those has a next pointer and surely at least one other pointer to or a node or something. And in order to carry out the same transformation in an instance of a subclass of delayed transformation, you would need, I mean, it needs to be on a list. So, you know, it has a next pointer. It needs the same information that was already there in the list entry. So at least the, you know, node or tree pointer or whatever. So let's say it has a next and a node, and then there's going to be a V table. Like basically all you're adding is the V table pointer. And so even with the smallest ones, I think you can get it down to 50% larger per entry without a ton of effort. Although I guess you know, if it's a priority queue, then I guess everything is a bit different, right? Then you're going to have a, I guess you could have something like a factor of 2 if you're flattening it into a flattened left complete heap or whatever.
Right.
But it would save all the next pointers at the same time. So okay, so there's that, and then I wanted to say that I like solution 3. Although I missed solution 1, sorry. But I think the only concern about solution 3 seems to me, you know, other than this memory issue, which in my estimation is probably not a big issue. The only other concern seems to be error proneness of declaring the order in which the transformations need to happen, like, you know, what dependency. But I think that's really just surfacing fuck complexity that exists, right? Like no matter what we do, they're going to happen in some order, right? And whether we, you know, like the way in which we make that explicit is just that's going to vary, right?
Right.
And I do think that if you try to start looking at, oh, well, I'm trying to inline, but, you know, something is weird about the CFG, or like, you know, I think that we are going to have to tell it what order to do the things in. At least that's my intuition on that.
Thanks, Devin.
I also think solution 3 seems like the best approach. And if that ends up being the approach adopted, then instead of calling it just delayed transformation, maybe we can specify VP delayed transformation. Because right now it sounds like anyone could use it.
Right. Yeah. No. I think in my prototype I had. I can't remember whether I had the VP on there or not. I might have. But yeah, that's a good point.
So if you're going to go down this path and let's say do something like option 3, that means that any project that is extending OMR that is currently that is making this extension in OMR, like they already have their own do delay transformations, they will have to make changes as well, right?
Yeah, so I guess it would be possible for OMR to I guess it would be possible for OMR to go ahead and make this change first. It depends on whether downstream projects are adding things to the lists that OMR defines. Yeah.
I mean, we can pull the projects that we know about, at least to understand the impact to them, and if there would be any consequences. But in the end, if this is the kind of change that you're going to have to make, I think just communication is key. Like lots of heads up on the changes that you're making, and we have to keep it maybe early in OMR release as opposed to like last minute. So at the beginning of a quarter, essentially, is when you'd want to drop change like this.
Right.
But I mean, I can poke the projects that I know about to let them know that there might be some changes happening on in VP that they may need to concern themselves with. I mean, I can get you guys connected if necessary.
Okay, sounds good. Yeah, I will, and depending on what other projects are extending VP and how we can, I can certainly manage how the change gets delivered so that there's as little disruption as possible, or the disruption is coordinated, well coordinated.
I mean, one way is maybe if it's possible, to make it completely independent of what's currently there. Like you build something off onto the side. I would imagine you're going to be doing the work on OpenJ9, so you would maybe use OpenJ9, like OpenJ9 could connect to that new infrastructure, leaving the existing one there. And when we've done the proper communication, and let's say we get some confirmation that the other downstream projects have made any necessary changes, then we can remove that existing code. So.
All right. Yep.
People have to define an order. Will you be guiding, or will there be some guidance on how to?
I hope so. I was experimenting with ways of doing that, and I'm still trying to figure out how best to do it. So
yeah, sorry, there's two aspects. There's how to specify the order, but then also what is the conceptual sort of thought process I have to go through to say this is the right order. Like, should I be looking for transformations that do X, Y, Z, and if I do A, B, C, then I should, like, you know what I mean? Like,
yeah, and I don't know that I have a good sense for what things people need to look for, other than having run across this particular.
I am interested in that kind of thinking, though, because if you come up with those criteria, maybe we can check some of them in the code automatically.
Right. Okay.
All right. Any other questions from anybody for Henry on this proposal?
I guess just a comment on that checking automatically there. That sounded like something different from what I initially thought I was hearing, such as maybe you know, maybe the way that we express the ordering can be decoupled a bit from, you know, it's not just like, you know, this delayed transformation class happened before that transformations class, right? But maybe based on some kind of property to declare. So I don't mean that like that's not my idea. I just I think that that's the kind of thing that VJ was saying, like something like this one does inlining or this one does this or that. So maybe this isn't adding anything for other people, but
well, that's certainly a way of thinking about it. So I've seen Henry's making them notes here in the room. I don't know where we'll get to because I didn't do any thinking before this meeting, but I'd like to get to the point where some of this at least is detectable, and even if it's via an assert during testing or something.
Could you create an issue with just a quick summary of the solution you're going to go down?
Yes.
And maybe we can even attach the deck that you're using to that issue, just so that we have an anchor for any further discussion on this.
Yep.
I'll definitely mention me there in case it escapes.
I mean, like a GitHub
Yes.
OMR issue.
Yep.
One other thought is that I do think a partial order makes sense because, you know, surely there are lots of transformations that we might do that are independent of each other and could be done in either order. But maybe we should impose some kind of tie-breaking condition to sort of create more consistency in terms of the order in which they do happen to apply. I feel like that would help in debugging.
Right. Yes. Yes. That's
like
a
you
good
say, if you want to reproduce a problem, you know, you don't want it to be too dependent on, well, we added, you know, this type of delay transformation and then we added that one versus adding them in the other order or something like this.
Right. Yes. Yeah, that's a good point. Yeah, I was worried about the possibility of some randomness in the order in which things were applied. Yeah.
Okay, any more discussion on this topic? Okay, if not, thank you, Henry, for taking us through that, and hopefully we can move forward on some aspect of that proposal. That's the only topic we had for this week, so I'm going to close the meeting now, and we'll meet again in 2 weeks. Okay. Thanks, everyone. Bye.
Thank you.